Recently at CamTech, we have synthesized the 4-hydroxy and isopropyltryptamine as a part of our program in studying the monoalkyl tryptamines. And here we can see the crystal structure. Can you scroll down a little bit just to show the synthesis?
Yeah.
Okay. Yeah, so we started with 4-benzyloxyindole, did the speeder Anthony, reduced it with diborane, and then debenzylated, and we obtained the crystal structures of all the intermediates, and we shall look at that today. So the crystal structure of this compound is basically 4-hydroxy in the 4 position with an forming a intramolecular hydrogen bond with the nitrogen, and this is the so-called ergoline conformation, and this is the non-ergoline conformation of psilocin analogs. So the ergoline conformation resembles ergoline's LSD, and this one has the side chain pointed away from the 4-hydroxy. These compounds tend to be a little bit more selective, and the compounds that have the side chain in the ergoline conformation tend to bind serotonin 5-HT2-1A and dopamine D2 receptors. The most interesting thing is that we do find a conformation similar to this one in the receptor. Actually, this is not the main binding pose of psilocin, but we can see that also an ergoline-like conformation with an intramolecular hydrogen bond, all stabilized by another hydrogen bond from this asparagine 343. And if we can superimpose it, we can see it's a very similar binding pose, except the side chain is in the alpha versus the beta position. My other video I explained how psilocin binds most commonly. We can just rotate this dimethylamine 180 degrees, and then it will assume a bond with aspartate 155. In addition, there is a hydrogen bond to serine 242 with most tryptamines and LSD utilize this linkage. The most interesting thing is the tryptamines are symmetric, so you can kind of superimpose them and put nitrogen on the oxygen, oxygen on nitrogen, and you achieve C2 symmetry, and these side chains can bind in the approximately same position. And what we've noticed when we do modeling, that these monoalkyl tryptamines, norpsilocin, N-ethyl, propyl, isopropyl, and butyl, they do not bind in this conformation, they flip. Okay, that is what I find really interesting. So the 4-hydroxy binds to serine 242, and then the side chain binds to aspartate. The binding energies are about the same, but what implication this has on the pharmacology is still yet to be seen. This might give rise to functional selectivity, agonist trafficking. Maybe in the presynaptic, there is a different binding mode than in the postsynaptic sites, but this is also possible, right? So we won't know until someone grabs this and crystallizes it, but till then it's only a hypothesis. The anisopropylpsilocin, we crystallized it as a free base. The hydrochloride salt is unstable. The fumarate is completely insoluble in water. It has solubility of 1 mg per mil in DMSO. But basically, these are novel classes of tryptamines that we're examining, and I thought that this would be interesting to show to our audience. Thank you.